In this lesson, we'll talk about regression analysis and review Regression Analysis Toolkit in Scikit-learn. By the end of this video, you should be able to define what regression is, explain the difference between regression and classification, and name some applications of regression. Before we talk about regression, let's review classification again. In a classification problem, the input data is presented to the machine learning model, and the task is to predict the target corresponding to the input data. The target is a categorical variable, so the classification task is to predict the category or the label of the target given the input data. The classification examples shown here is one we have seen before. The input variables and measurements such as temperature, relative humidity, atmospheric pressure, wind speed, and wind direction. The task for the model is to predict the weather category associated with the input data. The possible values for the weather category is sunny, windy, rainy, or cloudy. Since we are predicting the category, this is a classification task. With that context in mind, let's now discuss regression. When the model has to predict a numeric value instead of a category, then the task becomes a regression problem. An example of regression is to predict the price of a stock. The stock price is numeric and not a category, so this is a regression task instead of a classification task. Note that if you were to predict not the actual price of the stock, but whether the stock price will go up or go down, then that would be a classification task. That is the main difference between classification and regression. In classification, you're predicting a category, and in regression, you're predicting a numeric value. Here are some examples where regression can be used. We can use it for forecasting the high temperature for the next day, or estimating the average housing price for a particular region. Determining the demand for a new product, a new book, for example, based on similar existing products is also a regression task, as well as predicting the power usage for a particular smart grid. This is what the data set might look like for the regression task of predicting tomorrow's high temperature. The input variables could be the high temperature for today, the low temperature for today, and the month. And the target is the high temperature for tomorrow. The model has to predict this target value for each sample. Recall that in a supervised task, the target is provided, while for an unsupervised task, the target is not available or not known. Since the target label is provided for each sample as a numeric value here, the regression task is a supervised one, similar to classification. As with classification, building a regression model also involves two phases: a training phase in which the model is built, and a testing phase in which the model is applied to new data that the model hasn't seen before. The model is built using training data and evaluated on test data. Similarly, with classification, the goal in building a regression model is also to have the model perform well on training data, as well as generalize to new data. The use of two different data sets that we have previously discussed also apply to regression. Recall that the two data sets are used as follows. The training data set is used to train the model, that is to adjust the parameters of the model to learn the input to output mapping. The test data set is used to evaluate the performance of the model on new data or the leftover data. Something that we haven't discussed yet, but you will hear a lot in your machine learning class later on, is validation data. The validation data set is used to determine when stopping training in order to avoid model overfitting. In summary, in regression, the model has to predict a numeric value corresponding to the input data. Since the target is provided for each sample, regression is a supervised task. The target is always a numerical variable in regression. Next, we will discuss a specific algorithm to build a regression model.